Welcome all in my lecture Protein Structure Visualization Tool RASMOL. Interactive 3D visualization. RASMOL allows user to interactively explore and visualize the 3D structure of proteins and other biomolecules. You can rotate, translate and zoom in on structures for detailed examination. Multiple representation mode. It supports various representation modes including wireframe, sticks, ball and stick and space filling representations, which helps users view molecules from different perspectives. Color customization. Users can customize the colors for atoms, bonds and molecules, making it easier to distinguish different part of structure. Selection and measurement tools. RASMOL includes tools for selecting specific atoms or residues and measuring distances, angles and dihedral angles within the molecules. Scripting. It supports scripting using simple command languages, allowing users to automate tasks and create custom visualization scripts. File format support. RASMOL can read and display molecular structures in various formats including PDB, mole, XYZ and others. Using RASMOL typically involve these steps. Download and install. How we can download and install? You can download RASMOL from various sources and it is available for multiple platforms including Windows, Mac operating system and Linux. After downloading, install the software. Loading structures. Open RASMOL and load a molecular structure file in PDB format using the file menu. Visualization. Interactively visualize and manipulate the 3D structure using the mouse and menus provided by RASMOL. You can change representation style, color and more. Analysis. Use RASMOL tools to measure distances, angles and perform simple structural analysis. Scripting. If you want to automate certain tasks or create custom visualizations, you can use the built-in scripting languages. Export. Save images or sessions for future references or publication. RASMOL was widely used in the past, especially in educational settings and for basic molecular visualization needs. However, it is worth noting that the development of RASMOL has slowed down over the years and it may lack some of the advanced features and capabilities offered by more modern molecular visualization software like PyMol, Chimera and VMD. Researchers and educators often choose newer tools that provide a more extensive range of features and active development communities. Now, my colleague Josna will explain in detail about the RASMOL.
Hello everyone. Today's lecture is on structural visualization tool. Software used to examine and display structure information of biomolecule like amino acids are called structure visualization tool. Before visualization software was developed, molecular structure were presented by physical model of metal wires, rods and sphere. With the development of computer hardware and software technology, computer graphics program was developed to visualize and manipulate three-dimensional structure. The computer graphics helps to analyze and compare protein structure to gain the function of protein. One of the goal of this lecture is to allow you to become familiar with the program so that it will be useful for study of variety of macromolecules. Molecular visualization tool are software application or program that allow scientists, researchers and students to visualize and manipulate three-dimensional representation of molecule. These tools are essential for studying the structure, properties and interaction of molecules in fields such as chemistry, biochemistry, biology and material science. Molecular visualization tools help the scientists to bioengineer the protein molecule. User-friendly graphics interface makes this area of bioinformatics a scientific thrill to the bioscientists. There are number of software, both free and commercial, are available to visualize biomolecules. Commonly used software for structure visualization are PyMol. PyMol is a widely used molecular visualization program that provides a range of features for visualizing and analyzing molecular structures. It is known for its versatility and extensive scripting capabilities, making it a favorite among researchers. UCF Chimera. UCF Chimera is a powerful and extensible molecular modeling and visualization software developed by University of California, San Francisco. It supports a wide range of molecular file format and offer advanced tool for molecular graphics and visual analysis. VMD, Visual Molecular Dynamics. VMD is a specialized tool primarily used for visualizing and analyzing molecular dynamics simulation. It is particularly useful for understanding the behavior of biomolecules over time. JMOL. JMOL is an open source Java based molecular viewer that can be embedded in web pages. It allows user to interactively view and manipulate molecular structure directly in the web browser. Avogadro. Avogadro is an open source cross platform molecular editor and visualization tool. It provides a user friendly interface for building, viewing and analyzing molecular structure. ChemDraw. ChemDraw is a popular chemical drawing and molecular visualization software suite used by chemists and researchers for creating chemical structure and visualizing them in 3D view. Discovery Studio. Discovery Studio is a comprehensive molecular modeling and simulation package that includes visualization tools along with tools for drug discovery, protein modeling and other molecular biology tasks. Maestro. Maestro is a molecular modeling and visualization software developed by Schrodinger. It is commonly used for drug discovery and protein structure analysis. ResTop. ResTop is an open source molecular visualization tool with a user friendly interface. It is often used in educational settings and is suitable for basic molecular visualization needs. RASMOL. RASMOL is one of the earliest molecular visualization program and is still used by many for its simplicity and ease of use. It is particularly suited for basic molecular visualization tasks. This tool vary in terms of features, complexity and platform compatibility, so the choice of which one to use depends on your specific need and preferences. Many of them are freely available or offer trial version for academic and research purpose, while some may require a paid license for full functionality. In this lecture, we will discuss about protein structure visualization tool RASMOL in detail. RASMOL is a molecular visualization program used for displaying and manipulating three-dimensional structure of biological macromolecule such as protein, nucleic acid and small molecules. It was originally developed in the early 90s by Roger Sayale and it has been widely used by researchers and students in the field of structural biology. RASMOL is used by hundreds of thousands of users worldwide to view macromolecular and prepare publication quality images. Here are some key features and information about RASMOL. First one is it supports PDB file format. RASMOL supports the visualization of molecular structure in protein data bank format, which is the standard file format used to store information about the 3D coordinates of atoms in molecule. Researchers and students often use RASMOL to view and analyze molecular structure to better understand their shapes, interaction and functions. User can open PDB files and visualize the atomic coordinates of the molecule. 3D visualization. RASMOL provides interactive 3D visualization of molecular structure. User can rotate, zoom and pan to explore the molecule from different angles. Rendering option. The software offers various rendering options to display molecular structure including wireframe, sticks, spheres and ribbons. User can choose the representation that best suit their needs. Coloring and labeling option. RASMOL allows user to color the molecule based on different criteria such as atom type, chains, secondary structure. It also supports labeling of atoms and residues. Scripting. Advanced users can create scripts in RESMAL to automate tasks and customize the visualization. This feature is useful for generating complex visualization or animation. Command line interface. RESMAL can be used from the command line with various command line options which can be useful for scripting and automation. Cross-platform. RESMAL was originally developed for Windows, but it has been ported to various platforms including Linux, Mac. It was available as both graphical user interface and a command line tool. Open source. RESMAL was initially released as a freeware, and an open source version called OpenRESMAL was developed to continue its development and maintenance. Educational and research use. RESMAL has been widely used in educational setting for teaching molecular biology and biochemistry. It also used by researchers and scientists for analyzing and visualizing molecular structure. RESMAL primarily supports the protein data bank file format for the visualization of molecular structure. The PDB file format is widely used standard for representing 3D structure of biomolecule such as protein, nucleic acid and small molecule. In addition to PDB files, RESMAL can also handle related file formats and some other formats, although its primary focus is on PDB file. Here are some of the file formats that RESMAL can typically handles. Protein data bank file format. This is the primary file format for representing protein and nucleic acid structure. It includes information about the 3D coordinates of atom in the molecule, as well as metadata such as molecule name, authors and experimental method used to determine the structure. RESMAL can read and display PDB file. Alchemy. RESMAL can read alchemy file format which were used for 3D molecular structure. Gaussian cube. RESMAL can read Gaussian cube file format commonly used in quantum chemistry for representing electron density and molecular orbital. MDL mole file format. RESMAL has limited support for MDL mole file format which are commonly used for small molecule structure. ChemDraw. While not a native format, RESMAL can import ChemDraw files, that is .cdx, to some extent, although compatibility may vary. XYZ format. RESMAL can read XYZ files which are simple text based file representing molecular structure in Cartesian coordinates. Installation and downloading of RESMAL software. Instruction for downloading and installing a current version of RESMAL can be found at the openresmal.org link website. Linux, Mac and many other binaries are available. The latest stable release is 2.7.5. Here is a general outline of how you can install RESMAL on different platforms. For Windows, download the Windows version of RESMAL from the trusted source. Be cautious when downloading software from the internet and try to download it from a reputable source if possible. Once the download is complete, locate the installer file, usually with a .exe extension, and double click it to start the installation process. Follow the on screen instruction to install RESMAL on your Windows system. After installation, you should be able to run RESMAL by searching for it in your start menu or by double clicking its icon on the desktop. For Mac system, there might not be a native Mac OS version of RESMAL, but you can try using Wineskin or a similar application to run the Windows version on Mac system. Here is a general outline to download the Windows version of RESMAL from trusted source. Download and install Wineskin binary from the official website, that is wineskin.urgesoftware.com. Launch Wineskin binary and follow the instruction to create a new wrapper. In the wrapper creation process, specify the Windows RESMAL installer as the executable to install. Complete the wrapper creation process and it will generate an application bundle for RESMAL. You can then run RESMAL on your Mac system by launching the created application bundle. Installation for Linux system. RESMAL has been made available for Linux through various repositories and third party packages. You can search for Rasmol in your distributions package manager or use the command line to install it. For example, on Ubuntu or Debian based system, you can use sudo apt-get install Rasmol. On Red Hat or Fedora based system, you can use sudo dnf install Rasmol. The package name may vary depending on your distribution. Once installed, you should be able to run Rasmol from the terminal by simply typing Rasmol. Keep in mind that Rasmol is an older software tool and its compatibility with modern operating system may be limited. If you encounter issues during installation or while running Rasmol, you may need to explore alternative molecular visualization software with better compatibility and support. To retrieve PDB file from the RCSB database, 3D molecular coordinate files for protein and nucleic acid are stored in Research Collaborative for Structural Bioinformatics protein databank file of query protein can be retrieved from RCSB database. The input file can be in .pdb format. These files have been uploaded by researchers who have characterized the structure of molecule by X-ray crystallography, nuclear magnetic resonance spectroscopy or cryo-electron microscopy. The PDB file format is a textual file format describing the three-dimensional structure of molecule held in protein databank. It can be read in Notepad in case of Windows system, gedit in case of Linux. Rasmol can read and interpret .pdb file and allowing the user to visualize and manipulate the 3D structure of the molecule described in this file. A typical PDB file describing a protein consists of hundreds to thousands of lines like presented in this figure. Here is a simplified example of what a PDB file format might look like. In this example, header provides metadata about the molecule. It also provides information about the researcher who defined the structure. Numerous other type of records are available to provide other type of information. In PDB file, remark 350 bioempty record describe how to compute the coordinates of the experimentally observed multimer from those of the explicitly specified one of a single repeating unit. SAQ-RES record give the sequence of the 3 peptide chain named A, B and C, which are very short in this example, but usually consist multiple lines. Atom record describe coordinates of the atom that are part of the protein. Atom line contains information about individual atom in the molecule, including their atom type, atom number, atom name, residue name, chain identifier and 3D coordinates. For example, the first atom line in this example describe the alpha N atom of the first residue of peptide chain A, which is a proline residue. The first 3 floating point numbers are its x, y and z coordinates and are in units of Armstrong. The next 3 columns are the occupancy, temperature factor and the element name respectively. Heteroatom record describe coordinates of heteroatoms, that is those atoms which are not part of protein molecule. Loading a file into Rasmol. For this, just open the Rasmol folder and click on the icon that consists of 3 connected sphere labeled raswin.exe. An empty window with a black background will appear on the screen. This is called the main window. Under the file menu, open the 2hsb.pdb file where you have downloaded it. When a PDB file is first loaded into Rasmol, it is displayed in a wireframe representation, which is a Rasmol's default display mode as shown in this figure. Other display modes are also available, which we will describe below. Some of the mouse operation for moving the molecule which is displayed in the screen is the simplest operation are those involving moving the structure about on screen using the mouse. Each operation is achieved by holding the relevant mouse button down with or without either the shift or control keys and moving the mouse. The different operations that can be performed are Operation action. Left mouse button rotate XY coordinate, XY angle. Shift key plus left mouse button zoom in and zoom out. Shift key plus right mouse button rotate the Z coordinate. Control key plus left mouse button slab pen. Other menu bar are display option. In display option, there are different ways of displaying the uploaded molecule. This display option allows you to flip between different representation of the molecules. They are, first one is the wireframe. Molecule shown as a series of intersecting lines which represent bonds, reveals bond distance, angles and the overall geometry of the molecules. Color denote the atom that from the covalent bond denoted by the dotted lines. Red color represent oxygen, light blue color nitrogen, yellow color sulfur, light grey color carbon. In backbone display, a grey rod showing geometry of the backbone or main chain of the protein. These cylindrical lines are or rod connects adjacent carbon. Sticks display. Similar to wireframe, only the bonds are thicker lines. See #1 for color coding. Space fill display option. It represents atoms as a sphere with van der Waals radii. Ball and stick option. Atomic nuclei are shown as a colored sphere of identical size, bonds as a connecting stick. Ribbon display. Main chain shown as a thick grey ribbon that traces the backbone of the molecule, clearly reveals those regions of the molecules that form a helix and beta sheet. Strands display. It is similar to ribbon, but now a series of grey lines trace the main chain or backbone of the protein. Cartoon display. In general, it is similar to strands and ribbons, but shows non-alpha helical and non-beta sheet region of the molecule as a grey rod. Backbone in general appearance, but is smoothed to form curves rather than straight line between alpha carbon. Note arrowheads on the beta sheet, allowing one to discern the parallel or anti-parallel nature of the association of the strands. Next menu tab is color option. The color option allows you to color the uploaded molecule. The first option is monochrome. Single color molecule becomes white. CPK, the atoms colored by element type, carbon colored in light grey, oxygen colored in red, nitrogen colored in light blue and sulfur colored in yellow color. Next option is shapely. In these options, residues colored by amino acid property. Group option. In these options, residues colored by their position in a macromolecular chain. Each chain is drawn as a smooth spectrum from blue through green, yellow and orange to red. Chain option. In these options, each chain given a different color. Temperature. In temperature option, atom colored according to their anisotropic temperature factor. Assign amino acid color according to the degree of mobility, uncertainty in their position as given in the crystal coordinates. High values in red color, lower values in blue color. Try wireframe and note that the surface residues have the higher values. Structure option. In structure option, molecule colored by protein secondary structure. Alpha helix are colored in magenta, beta sheets are colored in yellow, loops are colored in blue and the remainder of the molecule is white with shade of grey. It is quite effective with the molecules in the carbon, ribbon and strands configuration. User option. User defined in PDB file. Next tab is option menu. In option menu, there is a first option is slab mode. It allows you to slice your way through the one plane of the molecule by rotating it. Hydrogen option reveals hydrogen atom, none in the 1jy sub a .pdb file. Heteroatoms shows non-protein atoms. Specular option. It enhances 3D effects by providing highlights. Shadow option. It enhances 3D effects by providing shadows. stereo option, it can give you a stereo image if you care to stare at the screen for long period of time, but it is not highly recommended. Label option, it will label all the amino acid and 3-letter abbreviation and numerical position in the sequence. It can get very messy with all of the amino acid named. However, it is possible to restrict the command to certain region or to enhance the resolution by zooming into region of the molecule. Next menu is the export menu. The export option allows you to output the current images of the molecule in various file format such as BMP format, GIF format, PPM and so on. The command window is where you can enter additional commands not available via the menu bar. The command affects the molecule displayed in ResMol graphics. Note that in Windows, the command window usually starts on the taskbar at the bottom of your screen rather than displayed on screen when you run ResMol. You need to click on its tab in the taskbar to get it to pop up. Through the command window, you can enter a wide range of interactive commands, each typed as a ResMol double inverted comma prompt. Each command must be given on a separate line. Keywords are case sensitive and may be entered in either upper or lower case letter. All white space characters are ignored except to separate keywords and their arguments. Certain commands have an on-off nature. You can type command on to switch on the command and you can type command off to switch off the off. For example, if you want to show your molecule in wireframe, you can just give the command on ResMol command window wireframe on. If you display all currently selected atoms in wireframe mode, and if you want to off the wireframe display, you can simply give the command to wireframe off. Switch off any wireframe bonds among the currently selected atoms. Some of the on-off commands also have an alternative version in which a number can be entered in place of on or off. For example, the wireframe command can be entered as ResMol wireframe 0.2. This switches the wireframe mode on but makes all the bond 0.2 Angstrom thick. The other on-off commands include are wireframe on-off, it display wireframe. The above on-off commands operate on all currently selected atoms. By default, this will be all atoms in the structure. Selection is performed by the command. ResMol select command, where atom expression defines the atoms required. Atom expression comes in several varieties. These include selecting one or more residue. If you want to select atom 3, just simply give command select 3. If you want to select more atoms, simply give the command select 3, 6, 9. Or if you want to give if you want to select a range of atoms, simply give the command select 12 to 25 or and so on. These 3 commands select a single residue, 3 individual residues and a range of residues respectively. Residues can also be selected using the full residue name, such as select TRP 100. This command will select tryptophan 100 atom. Selecting all residues in a single chain, just give command select *A. This selects all residues in chain A. Selecting all atoms, just give select * command. This will select all the atom in the structure. When any group of atom or residues has been selected, all subsequent operation affect only these selected atoms. Distance and angle command. There are several set picking commands which enables you to measure certain properties of picked atoms. Atoms clicked on the left mouse button. For example, if you enter the command ResMol set picking distance and then click on 2 atoms, ResMol will calculate the distance between them and display it in the command window. For this, the command is ResMol set picking angle. ResMol set picking torsion will calculate the angles and torsion angle between 3 and 4 successively successively clicked atoms respectively. Other useful picking commands are resmol set picking center, which allows the whole molecule to rotate about the next atom, that is clicked on. Resmol set picking indent shows the name of each atom clicked on. So, this is all about resmol visualization software. Hope so this information will be beneficial for you. Thank you.